Hi everyone! In this video, I would like to talk to you about vectors and scalars. These are the objectives that we are going to discuss in this video. Firstly, we are going to differentiate between the vectors and scalars quantities. Secondly, we are going to apply the vectors to solve some problems. And finally, we are going to resolve vectors into perpendicular components along the axis. So first, let's discuss scalars and vectors. So this page shows us the definitions of scalars and vectors quantity. Scalars are quantities that can be completely described by a magnitude or size only. They are expressed as a positive or negative number and a unit. Vectors are quantities that need both magnitudes and direction to describe them. And the magnitude of the vector is always positive. Some scalar quantities such as mass are always positive, while others such as electric charge can be positive or negative. So these are examples of some scalars and vectors quantities. Scalars quantities include speed, power, distance, work, and time. These quantities have only size or in other words magnitudes. On the other hand, vectors quantities include velocity, accelerations, displacement, force, and impulse. These are vectors quantities because they have both magnitudes and directions. Displacement and distance are using the same units, which is meter, but displacement has the directions and so classify as vectors. So let's start using the vectors and apply them in some programs. So for additions of vector, if two similar vectors point in the same directions, we can just simply add them together. And from simple arithmetic, we know that 4 cm plus 5 cm is equal to 9 cm, for example. And as you can see, there are two arrows shown, and they are pointed in the same directions. The green one has the magnitudes of 5 cm, and the orange one has the magnitudes of 7 cm. So we just simply add 5 to 7, which give us 12 cm as answer. So how about the vectors that pointed in the different directions? And in this type of questions, we can add vectors by using head-to-tail methods. There are vector A and vector B that pointed in the different directions. And so we just simply move the vectors B by using head-to-tail method, and we put the tail of the vector B to the head of the vector A. Then we draw a resultant line which shown in a black line. So this black line should give us the answer to the directions of these two vectors. Now let's try harder questions. Suppose you work 40 meter due south and then 30 meter due west. And we are going to determine how far and in what directions your starting points. First, we draw a sketch like this according to the questions to make us understand what the question talking about more easily. Then we can apply the Pythagoras theorem, and we have AC squared equals to 40 squared plus 30 squared. And so AC is equal to 50 meter. And for the angle, we can apply the tan ratio, and so tan ratio is equal to opposite over adjacent, which is BC over AB in this case, and it is 30 over 40, which gives 0.75. So 0.75 is equal to 36.9 degrees. So the final answer for these questions is 50 meter in a direction south 37 degrees west from the starting point. So how about the subtractions of vectors? It is quite simple if two vectors are going in opposite directions. You just subtract one from another. Let's take an example. For instance, a man works 54.5 meters east and then 30 meters west. And we are going to calculate his displacement relative to where he started. So this is very simple, and we just subtracted 30 meter from 54.5 meter. And the answer is 24.5 meter in the east directions. So let's solve one more questions to be familiar with this type of questions. For example, a board moved with a velocity of 50 meters per second due north in a river which flows with a velocity of 80.0 meters per second west. Calculate the board's resultant velocity with respect to due north. So again, we are going to apply the Pythagoras theorem. So resultant velocity, which expressed in purple dotted line here, is equal to root 8 squared plus 15 squared. And the answer is 17 meters per second. And for the angle, again, we are going to apply tan ratio. So tan theta is equal to 8 over 15 is equal to 0.53333, and this is 28.1 degree. So the final answer is 17 meters per second and 28.1 degrees west of north. So now let's resolve vectors into two components. So this is a basic concept, and in x components it is a cos theta, and for y components it is a sin theta. So let's resolve vectors into two components. So for example, a skyrocket is launched from the ground at an angle of 61 with an initial velocity of 120 meters per second. Determine the components of this initial velocity. So first, as you can see, the diagram is shown here. X component is here and Y is here. So vertical component is Y and the horizontal component is X. So first, let's solve for the vertical components or y-axis. As we know that y-axis is a sin theta, so we can apply the concept and sin 61 is equal to y over 120, or y is equal to 120 sin 61. So which is 1.05 times 10 to the power of 2. So how about the horizontal components? From the concept, we know that x-axis is a cos theta. So in this case, we can apply these concepts, and a is 120, so 120 cos 61 is equal to 58.2. So the final answer is the magnitudes of the vertical components is 1.1 times 10 to the power of 2 meter per second, and the magnitudes of the horizontal component is 58 meter per second. Thank you.